Hadoop come up with two beautiful components. What are they? One is Hdfs, other one is MapReduce. Other one is MapReduce. So already I have a distributed file system. Then why should I have a Hadoop distributed file system? Because when I load the data into employee, the data will go into a specific machine. And other one is I do not have a replica. I do not have a replica, no replica. And that it stores specific type of data. Specific type of data. What is the problem if it stores a specific type of data? If this machine goes down, let's say I have a server of my product is selling in Japan. I have a Japan server. The Japan server is crashed due to something. So I will lose the data. I will lose the data. I don't have a duplication. When I want to process the data which is there in India, I have to go with a single process, sequential process. I have to go with a sequential process, no parallel process. No parallel process. If that machine goes down, I have lost no data with me, no duplication, no duplicate data, right? These are the limitations. These are the limitations are there with the DFS. Then HDFS come into picture. These limitations are overcoming by HDFS. How the HDFS overcomes these problems, guys? Who will answer? Anisha? HDFS follows. HDFS follows. HDFS is Hadoop distributed file system. It is not a database. HDFS is not a database. Guys, if anyone says that HDFS is a database, don't believe it. It's not a database. It is a file system. It is like a normal file system. It is a file system. What type of file system it is? It is a distributed file system. It is a distributed file system. So your HDFS also follows something called master slave architecture. It follows master slave architecture. It follows master slave architecture. How it will follows the master slave architecture? There will be one guy who calls himself as a master. There will be a guy who calls himself as a master. It's called master node. What is a node? What is a node? Anisha? Harika? Harika, are you able to hear me? I'm not able to hear you. And there is something called slave nodes. What is a node, Harika? What is a node, Anisha, Kishore? Anyone?
Node is nothing but a physical device which can store and which can store the data.
Very
Yes.
good. So node is a physical machine which is connected in the network, which can store some data, which can provide your service. Which can provide your service. It's just a physical machine or connecting point which is there in the network. Which is there in the network. So we have two type of nodes are required to do a Hadoop setup. How many type of nodes? Two type of. One is the name node, other one is data node. Other one is data node. And these data nodes are slaves and this guy is a master. And this data nodes will be, he will be keep sending a heartbeat. Every 3 seconds, they will be sending a heartbeat, a signal. Heartbeat, if it's a very technical term, you can just say it's a signal. Every 3 seconds, it will send RPC signal. What type of signal it is? RPC signal. What is RPC? Remote procedure call. Remote procedure call signal. How long? Every 3 seconds. Every 3 seconds. If your master didn't get the response or signals 3 times continuously, it assumes that that machine is not there. When you look this architecture, it looks like similar to manager and team members. Manager and team members, right? So manager will control the team, manage the team, who is doing what. So how to assign the work to whom, and who are all off and who are all coming to office. Suppose if any guy I have pinged, suppose you are there in office, I have pinged 3 times. You didn't respond to me. What does it mean? Either you're not at the in front of the computer or you didn't come to the office. Correct? The same way, here also, your data nodes will keep sending a heartbeat signal to a name node. Heartbeat signal to a name node. Name node will be keep track of all data nodes. Keep track of all data nodes. Now, coming to the differences, DFS with the HDFS. Coming to the differences with the DFS with the HDFS. Even though here also you have connected multiple machines. Even here also you have connected multiple machines in the distributed manner. In the distributed manner. Here also it will maintain a layer on top of all these machines. This layer is nothing but HDFS. Even though underneath I have multiple machines are connected, I no need to worry. For me it is a single path. 100 machines are there, I don't know. I don't need to connect to 100 hard disks. Here also the same. If you have 100 hard disks, you no need to connect to 100 machines separately. You just connect to only this. Only this. You connect to only this path. It is for a single hard disk for you. You can store anything here. The same way here, I have connected 100 hard disks. I no need to connect to each machine separately. Student machine, go and connect to student machine. Employee machine, go and connect to employee machine. No, we no need to do that. You have to connect to only one layer, that is DFS layer. In case of normal DFS, in case of Hadoop DFS, you have to connect Hadoop DFS layer only. Clear, guys? Now, when I load the data here, we'll see very detail about the write flow and read flow later. When I suppose I want to I have some data which is Amazon data. Let's say I have data something called Amazon data. I have something called Amazon data. If I want to put employee data in this, how the data will write into normal file system or distributed file system? Any idea, guys? The data will be divided into blocks. The data will divide into blocks. The data will divide into blocks. Everywhere, you're not even even in a hard disk. Suppose you are writing some movie, you are storing some movie, or you are storing some notes, you are storing some songs. The data will load into blocks only. Here also same thing. When you're loading some employee data here, the data will load in here in the hard disk in the form of small blocks. Small blocks. The sequence of blocks. Load the data. While you're writing the data into this, it load the data in the form of blocks. Here also, when you're getting the data, when you're copying the data, when you're reading the data, it will also read in the form of small blocks. What is the block size in our local file system? It's very small. It can be 4 KB or something else. In the Linux environment, it's a 4 KB. Is there any automatic replication here? No, there is no replica. Zero. No replica. I mean, actually only one replica I can say. One means only one copy it will maintain. When it comes to Hadoop also, it will also load the data in the form of blocks. It will also load the data in the form of blocks. But here the block size is, what is the block size? here 64 MB or 128 MB. What is the replica here? Automatically 3 replicas, 3 copies it will maintain. It will maintain 3 copies. It will maintain 3 copies. What is a block? Block is a chunk of data, a piece of data, because the whole data cannot dump at a time. The whole data cannot dump at a time in the hard disk. It will read small pieces and put into hard disk. Either it's a normal file system, either it's a Hadoop file system, or if you take any file system, the data will write and read in the form of blocks. Okay, in this case of here, who deciding by operating system, in this case of here, Hdfs is going to define what is a block size and all. Here we can change the block. 64 to I want to change 32, I can change. 64 to 100 I can change. But here you cannot change in this. 4 KB is a fixed 4 KB only. Go ahead guys, if you have any doubts, please. Any doubt as of now? Okay, so let's say I want to put some data which is Amazon. I want to put this Amazon data into the Hdfs. So I'll be having a client. I'll be having a client machine. When I say command, so this is easiest command guys. So when I say Hadoop fs hyphen put, fs means file system, put and path of the Amazon and path of the Hdfs. When I give this command, what will happen? Your client will break this data into pieces because it will read only blocks, right? Even this is what happening in even in our normal file system also. Even in normal file system also, this is what happening. First, so why I'm repeating this multiple times? This is the very much basic. We should understand this. How the data is storing. What is a block? So first we should understand what is a block. It will divide the data into small blocks. So block 1, so block 2, block 3, block 4, block 5, and so on. Now, so as we discussed yesterday, this is Amazon data. First, it will take the block 1. It will take the block 1 in the client. The client will take the block 1 first piece. It will go to a name node, asking I want my block size is 64 MB. My replication factor is 3. I want to load this block into machines. Please give me the machines. Then your name node refers, guys, a new terminology I'm going to introduce here. Your name node refers block placement policy and rack awareness. Rack awareness. First, it look for block replacement policy and rack awareness. It looks this algorithm. Based on this algorithm, I'll explain detailedly what is this algorithm, how it works. Not to worry, it's a very pretty simple one. And what it will do, it will pick 3 machines, because what is the replication factor? 3 row. 1, 2, 3, 4, 5, 6 machines. So it will take 3 machines for the block 1. So let's look at here, Amazon file. The block 1 came. This entry is keeping by your name node. Okay, block 1 came. So I have written with block 1. Let's assume that your name node is given machine 1, 3, 5 machines. Machine 1, machine 3, machine 5. The machines will give to the client in the form of ascending order. How it will give an ascending order? Based on client. Suppose client is near to the block 1, Yes, it will give the block 1 is first. Next is near to the block, not block, sorry, machine 1, data node 1. Client is near to the data node 1. Yes, give the data node 1 as the thing. So data node 3 is next to nearest. Yes, give. Data node 5 is the next to nearest. Give like. So based on the distance from the client, based on the network distance from the client, it will sort the IP addresses. It will sort the IP addresses and will give to the machine client. Now the client will connect to machine 1 because the first machine, right? Then he will start passing the data. He'll start passing the data. Client 1 will connect to client 5. Client 3. Client 3 will connect to client 5. They're all not client guys, sorry, data nodes. Client 1 connects to data node 1 only. I'm repeating. Once it receives the IP addresses from the name node, your client will connect to the data node 1, and data node 1 is already connected internally. They will be having the connections. Data node 1 will talk to data node 3 because he has the information. Data node 3 will talk to data node 5. Data node 3 will talk to data node 5. Client will talk to data node 1 initially and will be passing the information, and data node 1 will talk to data node 3. Data node 3 will talk to data node 5 because they want to store the data into 3 machines, that is one machine, third machine, fifth machine. Now block 1, because it cannot, your network cannot send 64 MB at a time, it will send through a packet, small packets. So it will send the 64 MB 64 KB packets, and it will send first to the name node data node 1, and the data node 1 will copy the same thing to data node 3. Data node 3 will copy same thing into data node 5. It means your block 1 is copied in what are the machines? 1, 3, 5. Your block 1 is stored in machine 1, machine 3, machine 5. So block 2 also the same. Block 2 also same. So let's assume that 1, 2, 3. Block 3 is stored in 3, 4, 5. Block 4 is stored in 4, 5, 6. Let's assume that this is how that data will store in a HDFS. Is everyone is clear? Anisha, Harika, Kishore, Sachin, Shravani,
Yes, sir.
right? This the first line is called what it is? First line is called file to block mapping. File to block mapping. This is called block to, this is called data node mapping. We need this information. This information is nothing but your metadata. Sorry guys. This information is nothing but metadata. This information will be there with,
Mm,
very good, with the name node. Okay, this is metadata. It will be there with the name node. Clear? Clear? Sachin? Okay. Oh, okay, fine. Sachin, I understand. Yeah. At least you guys can just type and respond to me. Right? Sunil, do you understand what is the DFS? Sunil, do you understand what is the DFS?
Yeah, yes, I understand.
Okay, very good. So this is how the data will load into Hadoop cluster. Now try to understand one after one, what is the name node, what is the data node. We will try to understand it. Any questions? Please ask me, else we'll continue next one. Now try to understand name node. What is the name node, guys? Anyone? What is the name node? What is the name node?
Namenode is a master node which maintains all metadata information about the where blocks are stored in each of the data nodes. And whenever a request comes from the client, it will provide the data nodes based on the network cluster.
Very good, very good. Name node is a master node. Name node is a master node. He is a master node who stores who manages the cluster. Who manages the cluster? He will maintain the data in the form of meta store. He will stores the metadata. Stores metadata. He will not store actual data. Guys, he will not store any the actual data. Does he store any Amazon data? No, he didn't store any actual data. He stores only metadata. He stored only metadata. And who will take the request from the client and who will respond to him. And your master is single point of failure. Name node is single point of failure. It's a single point of failure. What is a single point of failure? If your name node goes down, you cannot access the data. But there are alternative, guys. Now there are very good alternatives. We'll talk about them, but so you will see one after one. Okay. Name node is a master node and who stores the metadata and who manages the cluster, and who is a single point of failure. If the master goes down, we cannot store or we cannot retrieve any data. If he goes down, your cluster is not able to accessible. Your cluster you cannot access. Okay. What is the roles and responsibilities of name node? What is the roles of name node? The roles of the name node is maintaining the metadata, and keeping the cluster and observing the cluster or monitoring the cluster, and whether the people are sending me heartbeat or not, and one more task you will do. The metadata, we're talking about metadata. Where the metadata will store? Where this metadata will store? Anyone? Where in the sense which memory? There are two types of memories we have, RAM and ROM. We have two types of memories. Where the metadata will store? The metadata will store RAM as well as ROM. In the RAM, you guys know it will be in objects. The data is storing in the RAM in the form of objects, namespaces. Why they call as a name node? Because name node maintains namespace. What is my address out here? Amazon address. Let's say /hdfs/amazon. So here my namespace is who maintains the namespace. Okay, namespace. Namespace is nothing but you have a root directory and you have a Hdfs. Here, this is the root directory. This is what I'm talking about. Okay, under Hdfs, it can have a Hdfs or something else. Here I can also say data. Okay, I can also say something else here. I can say Ravi as well. And under Hdfs, again Amazon. Let's assume that Amazon is the directory name. Under the Amazon file. Under Amazon, let's assume that Amazon.txt. Under the data, I may have something else. Here also I may have something else. Here also I may have something else. Here I may have something else. What it is? It is a tree structure. It is tree structure. Your name node maintains. Your name node maintains metadata information or namespace information in the form of tree structure. Those are called inodes. Those are called inode. Those are called inode. The path of the file. The path of the file. A path of the data. That is the reason it maintains the namespace. That is the reason we call it is name node. We call it is name node. That is, your data nodes will store the actual data. That's why we call them as data nodes. We call them as data nodes. Then there is no any other reason behind that. This machine stores data, call them as a data node. This machine stores only namespace information, call them as a name node. That is the only difference. Understand, guys? Understand, guys? Now the data will store in the form of in the RAM, which is in objects, in the ROM. Inside the ROM is nothing but your hard disk. The hard disk, the data will go in the form of two files. What are they? Edit log, or some people say edits. Other one is fs image. Fs image. One is edits, other one is fs image. Your name node maintains the data, metadata in the two files. One is the edits file, other one is fs image. We'll talk more about edits and fs image, guys. I'll show you the edits and fs image, and I'll also show you the content of the edits and fs image. I'll also show you the edits and fs image, because those are binary files we cannot see. Those are binary files we cannot see, but there are some tools from the Hadoop where we can see tools in the sense some commands. Okay, so there are some commands to see your edits file and fs image. I will show you that. Not to worry about the edits and fs image. We'll talk in the we'll talk about them very detailedly very soon. Understand about the name node? Understanding about the name node? Name node is a master node who stores the metadata and who is a single point of failure and who maintains the data in the form of name node. Namespace. The data will store in the name node as a tree structure. The data will go into two places. One is the RAM, which is a temporary memory, and another one is ROM, which is permanent. One place it will load the data into RAM, and one place the data will load into ROM. So why two places, sir? Why can't it be in single place? Anyone? Why it is storing two places? RAM and ROM? Stravani, Anisha, Harika, Kishore, Sunil. Any guesses? Or guesses, or with your experience you guys can tell. Why it is loading two places?
In RAM, it will be used for frequent access, Viral.
RAM frequent access. It doesn't mean it means if it is there in the ROM we cannot access the frequently.
No, but the speed of getting the metadata is very fast.
If it is in RAM.
Yeah.
Very good. So anything else? Any other guesses?
As RAM is a temporary memory power of the data will loss.
RAM is a temporary memory?
When power goes, we shut down the system, the data will loss from RAM.
Okay.
Erase from RAM.
So
next time it will fetch from ROM and process the data. So it's storing ROM.
Yeah, then why it is keeping in the RAM? Why can't it keep directly into ROM only?
So in RAM, for processing it, the data should fetch in RAM. So if it is data is in RAM, the processing speed will be lower.
Okay, very good, very good. Yes, guys. So if your cluster is running, or if your computer is running, or if your application is running, the data will be loaded into RAM. when your cluster is running, when your Hadoop is running, the information should be there in the RAM, because it has to, it isn't live. Live in the sense it is running, right? So when when the cluster is running, or when your application is running, when your software is running, that information should be there in the RAM for faster access. For any process you take in your mobiles or in your laptops, any process you take, when your application is running, where the application will run? The application will run in the RAM. So the whole information of the data, it's called metadata. That information, when the cluster is running, when the cluster is running, that metadata information will be available in the RAM memory. That information will be available in the RAM memory to faster access. And because RAM memory is a temporary memory, if something goes wrong with the machine, or if it goes the power off, or it is shut down, the data, whatever the data was there in the RAM, we will lose. So to avoid that, we will keep same copy of data in the hard disk. That is called ROM. Namenode maintains metadata in RAM while it is running, while it's and the remind the same data which will load into ROM memory for permanent storage. This is called persistent storage. That's called persistent storage. So in the form of two files, one is the edits and other one is fs image. One is edits, other one is fs image. What edit contains, what fs image contains? I'll tell you as high level now. We will see when in detail. We'll see in very detail in the next class. In the edits, it will maintain raw transactional information. Raw transaction information. What is a raw transaction? You are creating a directory. Yes, the entry will go into edits. You are creating a file. It will go into edits. So create, append, modify, remove. These three operations, these kind of operations, that information will go into edit log. That's called raw transactions. Creating a file or creating a directory, renaming a directory, or appending some data, or removing the data. These are all, each one is one transaction. So each one will have a transaction ID. Each one will have some information about that operation. That information will go into edits file. Then why fs image, sir? Why can't I use the edits only? Why should I need two files? Because the raw transaction information will be in edits, but your RAM is required. Your RAM is required only file system information. Where is the data? What is the size of the data? And what is the block size? Where and all it is stored? Your RAM is required, your name node is required to know only the file system information. So that's why, so we need, sometimes we also need the raw transactions. Okay, who done the transaction, who is the owner, when he has done, all the information is required. So that information will go into edits. The only file system information will go into fs image. That fs image will be loaded back into name node RAM. When it will be loaded back, I will tell that. We will see tomorrow very detail about your edits and fs image. Okay, try to come back again, try to recollect again. What is the name node? Name node is a master node. It stores the metadata. It stores the metadata in the two places. One is the RAM and ROM. If it is a RAM, it's a temporary memory. If it is a ROM, it is in a permanent storage in the local hard disk, not in HDFS, guys. It will store edits and FSM in name nodes hard disk. Name nodes hard disk, not in the HDFS. Okay, so it load into name nodes hard disk, where in the form of two files. One is edits and fs image. Edits and fs image. Edits contains the raw transactions. Fs image contains the file system information. And your name node is single point of failure. Single point of failure. It means if this machine goes down, we cannot recover the data. But you may say that there are some recovery tools where I can recover the data. Yes, we can do that. So let's take a scenario where it's completely burnout, you are not able to recover. That's why it's called as a single point of failure. And we are calling name node because it maintains the meta or namespace. It will maintain the namespace information. That's why we'll call as a name node. That's why we'll call as a name node. The name node maintains the namespace in the form of tree structure, in the form of objects, the form of tree structure, the form of objects. Is everyone is clear about the name node? Is everyone is clear about the name node? If you guys clear about the name node, we will discuss roles of the name node. We will discuss roles of the name node. Then we'll wind up today. We'll continue tomorrow. Okay. So if everyone is okay with the name node, then we'll see the roles of the name node now. Then we will close the session today. Tell me guys, is everyone is fine with the name node? Harika, Kishore, Sachin, Shravani, Sunil, Anisha.
Fine.
6 months time.
Anyone else? Sunil, any doubt? No. Okay, seems I can go with next one. What is the roles of name node? What will happen when the name node restart? What will happen when the name node restart? Anyone, what will happen when the name node restart? What will happen when the name node restart? Anyone? What will happen when the name node restart? Okay. Tell me, Kishore.
No, it's just it will go. It will lose the connection with the cluster for some time.
Okay. So when the name node restarts, yeah. Let me finish this. Okay. Yeah, I understand, Kishore. So it'll disconnect. I mean, it'll shut it down, everything, and all the data nodes cannot access the name node, and it'll go off. So we cannot access the cluster. Yeah, understand your answer. Okay. So roles of name node. So we know that managing and everything I'm not putting here. It's manages the cluster, and it is so keep observing the data nodes, and it'll keep assign some work when it comes. Not the data storage, when its processing comes, it will assign the work to the data nodes. It will assign the works to the data nodes. So that apart from that part, when the name node restart, we will lose the data which is there in the RAM. We lose the data which is there in the RAM, but your name node maintains, as I said, two files. One is edits, other one is fs image. One is edits, another one is fs image. This edits contains the raw transaction information. This fs contains the file system information. The fs will contain file system image, will contain file system information. The edit log will contain the raw transaction information. When the name node restart, the RAM memory will be cleaned, right? RAM will be cleaned. Nothing will be available in the RAM. So nothing will be available in the RAM. Let's assume that this is your name node. Name node will call NN, data node will call DN. Okay. So name node, when it restarts, will not be having any data. Then what it will do when it restart, after restarting the machine, the background, it will start reading your edit log. It will start reading your edit log. It will start merge with fs image. It will start merge with fs image, and it will create a new fs image. It will start merge with fs image, and it will create a new fs image. Merging in the sense, from the raw transaction information, I should know, no, because I have, see, now when the name node restarts, you should know where and all the data is stored, who are all my clients, I mean who are all my data nodes, that information this guy has to know, right? Who are all the users, that information should know by your name node, right? Otherwise he cannot functional, he cannot give a functionality, he cannot operate himself, right? To know that information will be available where? In fsimage. So at the time of restart, your name node will start merging edits with fsimage, this fsimage will be loaded back to name node memory. You may ask, why can't it load the edit log directly? Why is fsimage? Fsimage specifically file system information. So your name node RAM is required only file system information. It does not require any transactional information. Okay. After that, so you have a data nodes also. These data nodes also will start reporting him, saying that yes, we are part of your network only. They'll be keep sending in a heartbeat. They'll also start sending the heartbeat. So at the time of, they also start sending the heartbeat. At the time of merging, and these machines are sending the heartbeat, that duration, your cluster will be in safe mode. Your cluster will be in safe mode. What is the safe mode, guys? What is the safe mode, guys? What is the safe mode in Windows? When you shut it, your machine is gone down. Some files, OS or related files are corrupted. When you restart, it will ask you to go enter in the safe mode, and you try to recover it, or you try to do something. In the safe mode, you cannot install any software, but you can access them. Correct? Here also, when your cluster is in safe mode, you cannot write any data. No write operation. But you can read the data. You can read the data. If a cluster is in safe mode, you cannot write a data, but you can read the data. When it will go into cluster, at the time of merging edits with fsimage, at the time of it receiving the heartbeat from the data nodes. Then when it will go out from the safe mode, Ravi, you said it will go in safe mode. Then when it will come out from the safe mode, there are some configuration for it. But when it receives the information from the data nodes, suppose 80% of the data nodes are reported him. 80% of the data nodes are reported him, saying we are all alive. And when this merge process is done, your data nodes are reported him, we are alive, I am part of you, I am part of you. When the 80% of the data nodes are reported, your name node will come out from the safe mode automatically. Safe mode will be off. Automatically. It will come out automatically from it. So you have configurations where you can change the percentage, where you can change the wait time and all, and where you can change some information. I'll show you those things as well. Not to worry as of now. I'll show all the information, what to change, where to change. Clear? So if anyone asks what is the safe mode, you have to inform this is the safe mode. When the cluster is in safe mode, you cannot write the data, but you can read the data. It means no put operations, no create operations, no append operations, no. But you can read the access. You can only get operation, copy to local operation, that kind of operations you can do. Understand, guys? This is very much important thing we need to remember. This is very, very much important thing we need to remember. Any doubts? Any doubts? So yeah, that's it for today. We'll continue tomorrow. And if you guys have any doubt, please stay back and others can leave for the day.